The aim of the experiment is to study the relation between the frequency and length of a given wire under constant tension using sonometer. Also, we can calculate the unknown frequency of the tuning fork. Apparatus needed are sonometer, then tuning forks, slotted weights, rubber hammer, etc. Okay, and the principle used is the frequency is directly proportional to the length of the vibrating segment of the wire. That is, n is proportional to 1 by L, or we have to prove that n into L is equal to K, a constant. Okay, so now we can see how to do the experiment. We have to verify the law, that is n into L is equal to a constant, that is frequency into length is a constant. For that, what we can do is, first of all, we will stretch the wires of a sonometer by using suitable weights. Suppose we are taking 2 kg or 2.5 kg and we will hang it on the weight hanger that we can see in one end of the sonometer. Okay, and after that we will keep the bridges close to each other. Okay, so these two are the bridges that we will keep close to each other, and in between the bridges we have to keep a small paper, that means a paper rider, that we will keep at the center of the bridge. Now we have to select a tuning fork of any frequency and then we can excite it by using a rubber pad. When it excites, we can keep the stem of the tuning fork on the sonometer box. Then we can see a small vibration in the paper rider, and then we will adjust the bridge, that means the length we will increase gently, and we have to get the maximum amplitude. Okay, when the vibration is maximum, we can see that the paper rider will throw off. Okay, when it throw off, that length also we have to measure, that means the length between the bridges, that will be the length L, so that we can measure. After getting the first reading, that means the value of L, we have to repeat the experiment for the same frequency again, so that we can write it in the tabular column, that means length of the wire in the resonance with the tuning fork. So 1 will be the first length that we have calculated, then we will repeat for the same frequency and the value we will enter in the second column. Okay, then we can find the mean, and it can be found that we will be getting almost the same value for both the cases, that 1 and 2, because we are using the same tuning fork. So for the same experiment we have to get the same value, and we are repeating the experiment for reducing the errors. Okay, so now our first reading is over, and after that we will change the tuning fork. Now we can select any other tuning fork of different frequency and we will repeat the same procedure. That means we have to keep the bridges close to each other, and then we will keep the paper rider at the center, and then we can excite the tuning fork, and then we will keep the stem on the sonometer box. Then we can see the paper rider vibration. Then we will adjust the position of the bridges and make it fall. That means when the paper rider falls, then we can take the reading between the two bridges. That will be the length for the second frequency. Okay, now we will repeat the same experiment again, and after that we will write it in the tabular column. That means in the first case, here we can see length of the wire in the resonance with tuning fork L. So there 1 and 2. So we will be getting almost the same reading, and we can repeat the experiment for 2 or 3 frequencies only. Then we have to tabulate. Now we can move to the observations and calculations. Okay, so here we can see that constant tension on the string. So that is, suppose we are taking 2.5 kg on the weight hanger, so that weight we have to write here, and after that we have to fill the tabular column. Here we have first column as frequency. So suppose we are taking 480 Hertz as the first frequency, that we can write there, and the length of the wire in resonance with the tuning fork L, so that will be 1 and 2 is here, right? So in the first column we will write for the 480 hertz, how much length we are getting, that we can write. Suppose we are getting 15 as the length, so that value we have to write there. And the second one, the same experiment we are repeating with the same frequency, right? So that value we can write. So we will be getting almost the same value, that is 15 only. Now we can find the mean of that. Then in the next column, n into L we have to calculate. That means 480 into 15. Then last column is 1 by L, so that we have to find. In the same way we can write the second column also. Suppose we are taking 512 hertz as the frequency. In the second case we can write 512 in the first column, frequency. Then the corresponding length will be always less than 480 hertz, because as the frequency is increased, the length will be decreased. Okay, because these two are inversely proportional. So that we will get almost 10, 11, 12 like that. Okay, suppose we are getting 12, we can write that length as 12 there, and then find the mean as 12. Okay, then n into L, that is 512 into 12, so that we can write here and then find 1 by L. In such a way we will do the calculations and find the mean value of K. Also we can calculate the unknown frequency by using the equation n dash is equal to K by L dash. So that value also we can find. Now we have to draw the graph by taking frequency along x-axis and 1 by L along y-axis. So we can see that that is a straight line. Okay. Now we can write down the result, that is n into L is found to be a constant. Also frequency of the given tuning fork is equal to that much hertz. So now we can wind up the video here. If you like my video, please like, share and subscribe. Thanks for watching.